Hello everyone, welcome back to my channel Kitchen Chemistry with Imabest. In our last video, we talked about why carbon is chosen as the main element or atom in organic chemistry, and we saw what organic chemistry really is. Today we'll be talking about hydrocarbons, but before we dive into hydrocarbons, let me quickly remind us why organic chemistry exists and how organic chemistry came to be. So at first, chemists believed that those who study chemistry is everything around us, the food we eat, the air we breathe, the water we drink, so many things. So these chemists believe that these organic compounds, that's the plants and animals, were only from the living organisms. And they were thinking there is a special life force that is responsible for this compound. But scientists became very curious. They were just asking themselves, these compounds, can't it be synthesized in the laboratory? So they tried something and they discovered that the organic compounds can be synthesized from the simpler substance, and that's what changed chemistry entirely and led to the modern organic chemistry. So what happened here is that these plants and animals, the remains of these plants and animals were buried many years ago. They were buried under the earth, and over millions of years, because of what? Because of heat and pressure, these things were transformed to what? Transformed to coal, that is the fossil fuels, which is what? The fossil fuels, that is the coal, the petrol, and our natural gas. So all these things now, what do we call them? The coal, the petrol, and the natural gas. They are what? Hydrocarbons. You see, it's now taking us to what? Hydrocarbons. That is our lesson for today. Coal, the petrol, the natural gas are what? Hydrocarbons. And we've heard before, we've mentioned that in our last video what hydrocarbon is. The hydrogen, hydro, and carbons. Hydrogen and carbon. Compounds containing what? Hydrogen and what? Carbon. So chemistry is not abstract. Organic chemistry is not abstract. It's from somewhere. So we are not reading something natural. Sometimes people, when they hear organic chemistry, they'll be like, all these people that are so abstract, where are they getting all these things from? It's not abstract. So you can see what we're talking about, the hydrocarbons. So can you now see, from the remains of these plants, because of heat and pressure, transformed to what? Coal, petrol, and natural gas. That is the hydrocarbons. So now that we know what hydrocarbon is, carbon and hydrogen, and please, when we say carbon and hydrogen, no oxygen or nitrogen, just carbon and hydrogen. Please note that hydrocarbons are classified based on the type of carbon to carbon bond present. So we have the alkane, which is what? Single bond. Alkene, this is E, sorry. Double bond. Alkyne. Triple bond. You see, alkane, they always have what? A single bond. Alkene, double bond. Alkyne, triple bond. So hydrocarbons are what? Classified based on what? The type of carbon to carbon bond that is what? Present. Then for the alkane, example is what? Let's use ethane. Ethane is 2 carbon atoms, which I mentioned in our last video. I had my reasons for bringing all those things so that as we move on, all these things will not be new to you. Remember, carbon to hydrogen, carbon and hydrogen, the hydrocarbons. We are talking about just carbon and hydrogen for now. So this is it. This bond, this single bond is what makes it what? Alkane. So this is ethane. This bond, this is single bond. You'll be hearing saturated. Don't be scared. Saturated means what? That they have the maximum number of what? Hydrogen atom. Like if you look at the ethane, this bond now, that is one bond. This is 1, this is 2, this is 3, and this is 4. 1, 2, 3, 4. So they have what? Maximum number of what? Number of what? Hydrogen atom. Remember, carbon must have what? 4 bonds. Don't forget this rule. So saturated means what? They have maximum number of what? Hydrogen atom. Then you also be hearing of aliphatic. You'll be seeing something like this. Alkanes are what? Aliphatic. They are also saturated. Aliphatic is just that they are on what? I would say not ring. It can be a long chain, a branch. Anytime you see ring, any ring structure is not what? It's not aliphatic. That is aromatic. We'll get to that. So alkanes are what? They're also aliphatic and are also what? Saturated. You'll be hearing they're arranged in what? The aliphatic are what? Arranged in open chain, not ring. So open chain can be a long chain, it can be a branch chain. The alkanes have a general formula for you to use and draw the structure. Don't mind you, I'm just writing carbon to carbon. I see to this and be putting the I will show you the formula you can use to do all those things. It's very simple. So the general formula for alkane, Cn plus H2n plus what? Plus 2. So our N is what? Is the number of what? Carbon atom in what? In the hydrocarbon. This is N. I'm defining N now. Number of what? Carbon atom in what? Hydrocarbon. So if we say we are moving to naming, yeah, after this is naming very soon, so you understand it better. So if you use ethane too, and you know that ethane is what? 2 carbon atoms. That is, we just did that now. This is ethane. I want to confirm this structure now for you to see. Ethane is 2 carbon atoms. That is the number. That is the N here. Is the number of carbon atom in what? In the hydrocarbon. This is hydrocarbon now. Carbon and hydrogen. So the number of carbon atom, we have 2. Abi? So for the formula, Our number of carbon atom is what? Is 2. So we are now looking for what? We are looking for hydrogen. So here we have H2N plus 2. So we have 2 here times, don't forget our rows in our general maths, the basic maths. Yeah. 2 times what? The number of carbon atom, which is what? 2 here, plus 2. So this is what? 2 times 2 is what? 4 plus 2. 4 plus 2 is what? 6. So hydrogen now is what? Is 6. So this is ethane. If you count it, carbon is 2, 1, 2. Hydrogen is how many? 1, 2, 3, 4, 5, 6. So this is correct, and this is correct. Let's try that. Let's try another. Let's try butane, our cooking gas. Yes, butane. That is 4. But is 4. That is the carbon atom now is what? Is 4. Let's try that and see. Just follow it up. You will understand. Don't worry. I will not be fast. I'll take it slowly. The same formula, because we are talking about alkanes now. So butane, that is 4. It has 4 carbon atoms, right? So from the formula, the C is what? That is C4. The same. So we are now looking for what? The hydrogen. So here we have 2 already. That is, let me bring it out again. Plus 2. Hydrogen is what? 2 times the number of carbon atoms. Don't forget the N. N is what? Number of carbon atom is what? 4, right? Times 4 plus what? 2. 4 times 2 is what? 4, 2, 8 plus 2. 8 plus 2 is what? 10. C4H 10. Let's see if that can give us 10. Let's confirm. After drawing it, you have to confirm it too. So 4 carbon atoms, yeah. 1, 2, 3, 4. Remember, carbon must have how many bonds? 4. Surrounding it. So let's count. 1, count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hydrogen is what? 10. Even if I don't put the hydrogen, you know there is hydrogen here now. Don't forget that. Hydrocarbon, carbon, and hydrogen. That's it. When you count the hydrogen, you see that is what? Is 10. So this is correct, and this is correct. That is just for alkanes. So when we be doing naming, it will be very simple. And they said 5 carbon atoms. That is pentane. The number of carbon atom is 5. You put the 5, C5. Now you are looking for hydrogen. 2 times 5, 10 plus 2, 12. C5H12. Very simple. So for the alkanes, we just finished the alkanes. We've seen their structures, few examples, and that they are aliphatic and what? They are saturated. So let's move on to what? Alkanes, the second class. Remember, we are classifying hydrocarbons. The alkane, which is what? The double bond. The double bond. They have what? Double bond. They have a double bond. That is carbon That is a double bond. But alkenes, are they saturated or unsaturated? They are not saturated. Why? Remember what saturation means. Like we did the alkanes. We said they are saturated because of what? They have a maximum number of what? Maximum number of hydrogen atoms. This one, if you look at it, these two bonds, this is two already. Oh. This is two. The double bond, this bond here, is what makes it in alkene. So this bond now is two. It's two already. Remaining how many hydrogen? Only remaining two bonds for hydrogen. Now what? They are not saturated. They are unsaturated. But the funniest thing is, the more they are unsaturated, the more they are reactive. Do you understand what I mean? Alkenes are what? That is why they are more reactive than the alkenes. Alkenes are more reactive than the alkenes because they are what? Unsaturated. Then when you look at the alkynes too, you see that alkynes, they are still unsaturated because of the three bond inside, which gives room for just one hydrogen atom for each carbon atom, which will move to that, you understand. They are more reactive than what? The alkenes. That is chemistry. That is organic chemistry. It's not something abstract. You'll be seeing everything. You don't assume. The more you do it, the more you understand it. So alkenes are what? They are unsaturated. But are they aliphatic? Yes. They are aliphatic because they can still be on what? The long chain and the what? Branch. So alkenes are what? Aliphatic, but they are unsaturated and they are what? More reactive than alkenes. Example, this is ethene. Carbon to carbon double bond. That is two carbon atoms. Then propane, that is three. The carbon to carbon double bond can be in any position. Yes, for a longer chain, not necessarily mean it has to be the carbon at the end, the two carbons at the end, like carbon to this, everything must know. It can be carbon to this double bond before a single bond. It can be the other way around. This. It's the same thing. So the double bond can be anywhere. Let's look at the general formula for alkene. So for the alkene, the general formula is what? CnH2n. Can we try this for alkene? If the carbon atom is what? Is 2. Can you try this? Okay, let's look at it. The N is what? 2. That is number of carbon atoms. So here we have C2, H 2 times this. That is 2 times 2. We bring that down. This is 2 times the number of carbon atom, which is what? 2. So 2 times 2 is what? 4. Can we confirm that? So let's confirm that if it's correct. 2 carbon atoms. That is 2 to carbon double bond. Don't forget we are talking about alkene. In alkene. So this is double bond, carbon to carbon double bond. Gives room for how many hydrogens? 1, 2, 3, 4. 1, 2, Let's confirm if that is correct. Carbon atom is what? Is 2. How many hydrogen atoms? We just calculated it now. 4. 1, 2, 3, 4. So this is correct. 18. You'll soon get to naming. So this is F. 18. 2. So this is correct. It doesn't necessarily mean for, let's check three carbon atoms for that. So you won't think the carbon to carbon double bond is not just one though. They said at least alkenes must have what? At least one carbon to carbon double bond in their open chain. That is long chain or branch chain. So if it's 3 carbon atoms, remember I just mentioned that. There are some structures that when we get to naming, you'll be seeing yes, but if you see something like that, does not mean this is not also an alkene. That is propene. This is pro. Is 3. That is propene. 3 carbon atoms. This is also 3 carbon atom. This is also propene, like the parent name. It is also an alkene. Yes, 3 carbon atom, prop. So if you see one just carbon to carbon double bond, just one double bond, don't be confused. Don't be confused. As far as you've seen a double bond, carbon to carbon double bond in a chain or in an open chain, that means that is an alkene. Please. So 1, 2, 3, 4. But for beginners, you're making use of this formula. Let's confirm this structure. Let's see if this will be correct. And this is it. This carbon is complete. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That is complete, right? But for beginners, we are making use of the formula now. How many number of carbon atoms are there? 1, 2, 3. So N is what? 3. So now we want to confirm the number of hydrogen atoms here. Here we have H2N. So this is 2 times what? Number of carbon atom is what? 3. So 2, 3, 6. Let's count if we have 6 here. 1, 2, 3, 4, 5, 6. So this is correct. So you see, with the formula, you know how to write the structure. Very simple, it's straightforward. Just know the formula and you are good. You know the naming. You just look at the structure and you're already analyzing it. So it's very simple. So that is that for our alkene. So alkenes, don't forget, they are more reactive than alkanes because they are what? Unsaturated, and they are also aliphatic. Let's look at alkyne. Alkynes are what? The triple bond is a triple bond. That is carbon to carbon what? Triple bond. They are aliphatic, right? But are they saturated or unsaturated? They're unsaturated. If you look at the structure, this is 1, 2, 3, giving room for just one hydrogen atom to come in. 1, 2, 3, giving room for just one hydrogen. They don't have maximum what? Hydrogen atom in it. So they are what? Unsaturated. They are unsaturated. But they are more reactive than alkene and even alkanes. They are more reactive than alkenes. So the more reactive it becomes, So more unsaturated, more reactive. So alkynes are what? They are more reactive than alkenes. So let's look at the general formula. CnH2n minus 2. That's the formula for what? Alkyne. So let's try for carbon equals to 2. So the carbon atom is what? 2. So let's C2. We're looking for this. Looking for hydrogen. So this is 2 times 2 minus 2. 2 to 4. 4 minus 2 is 2. So hydrogen is what? 2. Let's confirm the structure. Don't always forget the bond. Alkynes are what? Triple bonds. So carbon to carbon triple bond. We're considering 2 carbon atoms, don't forget. So this is it. 2, 1, 2. Then how many hydrogens? So if you count 1, 2, 3, 4. That is complete. 1, 2, 3, 4. That is complete. Remember our hydrogen. So this is correct. And this is what? Correct. So with this formula, you can write and draw any structure and you name them very well. Please take note of the formulas. Please, we'll need them as we move forward. We'll quickly move to naming the hydrocarbons. It won't look strange to you as far as you know all these things. It started well. Just for you to know the number of carbon atoms and add the suffix. That's all. Number of carbon atoms. Their suffix. Number 1 we have 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8. Meth 1. F 2. Probe 3. Boot 4. Pen pens 5. Hex. We've been hearing of hexagon, those, that is 6. Hex is 6. Heb. Oct. This is what we've been hearing. Octet now. Yeah. Octet row in chemistry. Yeah. That is 8. 9. So the suffix now. So I'll have to divide the board, sorry. Don't forget for the alkanes. ANE. For the alkenes, ENE. That is the suffix. For the alkyne is what? YNE. It's just the name. Alkanes, I'll do it one by one. The alkanes, the meth is what? Methane. For 1. Eth 2. Ethane. Just be adding the ANE. So this is one carbon atom: methane, ethane, propane, butane, pentane, hexane, heptane. Just the number of carbon atom, the meth, the F, the prop, the but, the pent, and so on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And just be adding the suffix. For the alkanes is ane. Very simple. So that is it. A carbon atom doesn't stop at 10. We have all those other complex molecules that they have like 21 carbon atoms, 22 like the docosahexaenoic acid, and the other ones that are complex molecules with more than 10 carbon atoms. Not necessarily mean 10, or it stops at 10. There are more. So that is for the alkanes. Just be adding the ane to the carbon atoms. Then for alkene, we've done this one now. For alkene, propene, butane, pentane, hexane, and others. That is for alkene. That is for alkene. Then for alkyne, that is what? The YNA. This one now. Ethyne, propyne. Just be adding the YNA. YNA. This is YNA. Number of carbon atoms and their suffix. Just for alkane, alkene, and alkyne. The ANA, the ENE, and the YNA. When you know the basics, when you know it, there's no way you look at all those structures, you will not understand. I would like you to try these questions. Just pause the video and try this on your own. And you know, in organic chemistry, you don't just read the book and just leave it like that. You keep trying it. You keep looking at the practical questions. It will help very well. Each of my lessons, I will be giving you practical questions so you can look at it by yourself and you understand it better. Is from what we just did, though. It's not outside the lesson we just did. It's what we just did. So just try it and see if you can do that by yourself. You draw a methane. That is CH4. Name a hydrocarbon with, let me say, with 5 carbon atoms, and only, read the questions very well, only single bonds. Name a hydrocarbon with 5 carbon atoms and only single bonds. You need to get it right before you start. In chemistry, you don't just jump into answering those questions. You have to read it and understand very well, else you make mistakes. You can just look at, 5 carbon atoms with only single bonds. Don't forget that. So number 3 is, why Why are alkanes called saturated? And the last one, what does the term aliphatic mean? So I want you to try these practical questions. I want you to try them very well. Just organic chemistry is not something you just dump your book after the lesson, you dump it and off you go till the next video. No, you keep doing it, you keep trying it. The more you do it, the more you understand it. So I'll make sure I break it down for you to understand. Seriously, I'll break it down for you to understand very well. And you've seen, if you know hydrocarbon very well, that means organic chemistry becomes very easy for you. It will be very easy. There's no way you see a structure and that you will not be able to analyze it without someone telling you. So it makes it very easy for you. So in our next video, we'll go deeper in naming hydrocarbons step by step. Then we'll start solving problems together. Don't forget to like, share, subscribe, and turn on notifications so you don't miss the next lesson.